The forces at play on the surface of Betelgeuse portray a scene of continuous turbulence and disorder. This massive red supergiant, with a radius over 1,400 times that of our Sun, behaves in ways that defy traditional astrophysical expectations. In theory, a star of such size should evolve slowly, with changes unfolding over years or centuries. However, Betelgeuse experiences rapid variations in brightness, with its outer layers flaring brightly and then fading within just a few weeks. These rapid shifts are surprising and have led scientists to reevaluate the behavior of stars at the end of their life cycles. Observations now reveal that Betelgeuse hosts enormous convection cells on its surface. These are immense currents that transport hot material from deep within the star to its surface. Some of these convection cells are so vast they exceed the diameter of Mars' orbit. Their movement is unpredictable. They expand, collapse, and reform in dynamic patterns. When these cells collapse or erupt, they can throw vast quantities of gas and dust into space. From our perspective on Earth, such eruptions can obscure light, resulting in sudden dimming events that last weeks. At times, one hemisphere of Betelgeuse appears significantly darker, only to brighten again once the dust disperses. Astronomers describe this outer region as a state of stellar upheaval. This volatility has sparked significant discussion among scientists. One prevailing theory is that these dimming episodes are signals of Betelgeuse's impending supernova. According to this view, the star's core has begun fusing heavier elements like silicon and iron. Once iron begins to fuse, energy production halts, and the core collapses under its own gravity. This sudden collapse triggers a massive explosion, known as a supernova, which can rival the brightness of entire galaxies. Those who support this theory suggest that Betelgeuse's recent behavior aligns with models that predict how a dying star behaves just before it explodes. If this interpretation proves correct, humanity could soon witness one of the most significant celestial events in modern history. A supernova that close would be visible even during the day, shining as brightly as the full moon. Such an event hasn't been observed from Earth for over 4 centuries. Yet, not all astronomers agree. A large number remain skeptical, proposing that while Betelgeuse is certainly nearing the end of its lifespan, the current activity might not signify an imminent supernova. Instead, they believe it reflects a prolonged, unstable phase that could continue for decades or even centuries. From this perspective, the observed upheaval might be common for red supergiants, but previously unobserved due to limitations in past instruments. Before the advent of the James Webb Space Telescope, JWST, astronomers lacked the resolution and sensitivity to witness such detailed processes in stars like Betelgeuse. With Webb's advanced capabilities, we may now be seeing normal late-stage behavior of massive stars, a chaotic, yet typical, part of stellar aging. These events might have been happening all along in stars like Betelgeuse, simply escaping detection until now. This divergence in interpretations raises a compelling question. Is Betelgeuse about to go supernova, or are we merely witnessing one of its many tumultuous phases? No matter the answer, this moment holds exceptional value for science. It provides a rare opportunity for astronomers to refine existing theories of stellar evolution. Whether Betelgeuse is on the brink of its final explosion or merely undergoing temporary instability, the data it offers is invaluable. Some experts even suggest that Betelgeuse may be stabilizing. Despite its dramatic appearance, it might be transitioning into a quieter phase that aligns with the known behavior of aging stars. Even so, the information being gathered continues to reshape our knowledge of how such massive stars evolve and die. Perhaps the most breathtaking aspect of this saga is the image captured by the JWST. This high-resolution image is more than just a visual, it is a revelation. Rather than presenting a calm, fading star, the telescope showed Betelgeuse as a stormy, asymmetrical colossus. Its surface teems with swirling hot spots, gigantic plumes of gas, and immense convective currents. The image shatters the long-held belief that massive stars experience a graceful, orderly demise. Instead, it suggests that their final phases are chaotic, drawn out, and far more unpredictable than previously assumed. This single image has ignited both excitement and concern within the scientific community. If Betelgeuse is not following the expected script, could other massive stars also behave unpredictably? Might our existing models of stellar life cycles be overly simplified? The image doesn't just challenge our understanding of Betelgeuse, it questions the very foundations of how we perceive the evolution and death of stars across the universe. It marks a turning point in astrophysical thought, one that will likely influence research for decades to come. Beyond its scientific implications, the potential explosion of Betelgeuse carries profound emotional and philosophical weight. Should it occur in our lifetime, it would be a shared spectacle of staggering magnitude. A supernova that bright would captivate the world, visible during daylight and outshining the moon at night. Such a luminous phenomenon would not only be a marvel to behold, but also a deeply unifying experience for humanity. In an era dominated by digital distractions and rapid technological advances, a supernova visible in the sky could reawaken a collective sense of wonder. It would shift focus away from screens and toward the stars, encouraging people around the world to look up and reflect. The emotional resonance of such an event would transcend cultures and disciplines, inspiring art, literature, music, and renewed curiosity about our place in the cosmos. But the implications extend even deeper. A supernova represents the ultimate act of cosmic recycling. When a massive star explodes, it doesn't vanish, it transforms. The explosion disperses vast quantities of carbon, oxygen, iron, and other heavy elements into space. These materials seed the next generation of stars and planets, continuing the cosmic cycle. We are intimately connected to this process. The iron in our blood, the calcium in our bones, and the oxygen we breathe were all forged in ancient supernovae. The death of stars like Betelgeuse is the reason we exist at all. Witnessing such a supernova would be witnessing our own origin story unfold in real time. It would serve as a vivid reminder that we are not separate from the universe, but intricately woven into its fabric. This understanding imbues the potential Betelgeuse event with poetic grandeur. To gaze upon the fiery death of a star is to peer into the very crucible of life. The cosmos, in its endless cycles of creation and destruction, reveals a profound truth. In every ending lies the seed of a new beginning. Just as Betelgeuse might scatter the raw ingredients for future solar systems, our own lives are part of a greater story, an epic of transformation that spans time and space. In this context, the image of Betelgeuse becomes more than a piece of scientific data. It becomes a symbol of human curiosity, resilience, and our relentless drive to understand. The James Webb Space Telescope, with its powerful vision, allows us not just to observe the universe, but to connect with it. Each photon captured by its instruments carries with it stories of nuclear fusion, elemental birth, and the raw forces that shape galaxies and life. As we stand on the threshold of discovery, watching Betelgeuse with collective anticipation, we find ourselves already enriched, not merely by what might come, but by what we have already uncovered. The unfolding mystery of this massive red supergiant has granted us a deeper, more profound understanding of how stars live, evolve, and ultimately die. Thanks to the powerful observational tools now at our disposal, most notably the James Webb Space Telescope, we are seeing these celestial processes in a clarity and depth never before achieved. It is no longer just about speculation or distant theories. It is about real, tangible data that peels back the layers of cosmic complexity and brings us face to face with the majestic violence of the universe. The story of Betelgeuse is more than an isolated astronomical event. It is a symbol of a broader awakening in our understanding of stellar physics. Every plume of gas ejected from its surface, every unexpected dimming episode, and every convection current shifting across its fiery body tells us something about the mechanisms that govern stars many times larger than our sun. In the past, such observations would have remained blurred, imprecise, or entirely hidden from view. But now, with our new generation of instruments, the universe is revealing its secrets in ever more vivid detail. This moment also acts as a catalyst for human curiosity. The sheer unpredictability of Betelgeuse, its erratic behavior, its potential to explode in our lifetime, challenges the scientific community to rethink long-held models and compels a new generation of thinkers to ask fresh questions. What else don't we know about massive stars? What other surprises are waiting in the skies? These are not just scientific questions. They are invitations to dream, to wonder, and to continue reaching into the unknown. Ultimately, the spectacle of Betelgeuse reminds us of something far greater than itself. The universe is a place of endless mystery, grandeur, and motion. It doesn't always follow our expectations, and that's precisely what makes it so inspiring. As we continue observing, questioning, and learning, we participate in a legacy of discovery that stretches back through centuries, and will continue as long as humans dare to look upward. In this way, the story of Betelgeuse is not just about a star, it's about us. It's about our drive to understand, our willingness to confront uncertainty, and our endless fascination with the cosmos. No matter what the future holds for Betelgeuse, whether it erupts in a supernova tomorrow or centuries from now, we are already the beneficiaries of its tale. The universe, with all its unpredictability and brilliance, is urging us to stay engaged, to keep asking questions, and to never lose the sense of awe that makes exploration so meaningful. Because in the end, the most powerful impact of Betelgeuse's image is not just in what it reveals, but in what it awakens within us. A renewed sense of awe, a reminder of our cosmic heritage, and an enduring desire to uncover the mysteries that still lie ahead.